Hit it. You got this. Go.
No, I don't know.
Yes, you do. Come on.
It's like evaporation, condensation. What is like a monkey?
Yeah. Dang, that was good. Yeah, and thank you for going for it. I really didn't think you would. You have no shame. I love it. That's awesome. So that was great. That was the condensation boogie, the water cycle boogie. Water cycle boogie. My daughter sings it almost as well. Everybody knows the water evaporates from someplace. We forget how complicated it is that it moves around in the atmosphere. And in order to condense, there's a big detail. Does anybody know what's required to make the raindrops happen? One thing that's required is the dirt. But another thing that's also required is a change in temperature. The water vapor has to want to condense. Yeah, it has to have a place for the heat to go. You have to have a transfer of energy because water vapor is too excited to be water droplets. Water droplets are kind of chilling. But water vapor is like super hyper. So there has to be a place for the energy to go. You need that change in temperature, and then you get the precipitation. So here's a couple of things that are added to that now. Here's the evaporation that Maddie was singing about. But remember that evaporation comes from a lot of different places. So yes, the ocean. Also, transpiration is when plants breathe out. How did he do?
Well, I need to keep.
I mean, how did Chris do?
Oh, it's not all like there's nothing different there.
Right. But like 2 would probably be enough.
There are 2.
Yeah, I think so, right?
Yeah.
They're not going to be like.
No.
All right. Y'all be quiet. Somebody stop Lucy. And then there's evaporation from plants, evaporation from lakes, from streams, from the ocean. All these red arrows pointing up are different sources of evaporation. It's kind of important for you to remember water has to be absorbed before it can evaporate. So stuff that soaks up a lot of water will breathe out a lot of water. A meadow will absorb tons of water on the surface of the grass and into the dirt. And so then it'll breathe out a lot of water. You know, a rocky mountainside will mostly shed its water, so it won't evaporate as much as a meadow that absorbed a lot, so it can breathe out a lot. So we've got your evaporations, and then we've got your precipitation falling over here. Keep in mind, some of that stuff will run off on the surface, and some of the stuff will infiltrate, meaning it will enter the dirt. Then it will percolate, or it'll go through the dirt. And please notice that groundwater doesn't all make it to the ocean. Some of it goes into plants, and some of it comes out into streams before the remainder goes to the ocean. This is the water cycle boogie for high school level. Any questions about this? How many of you would like to hear Maddie sing it again?
Where's condensation?
It's happening in the cloud, where it says rain cloud. Thank you. All right. This one is the one that I think is a little bit harder for my students to understand. So before we talk about that, remember, if you're standing on dirt and that dirt is porous, there is water underneath you somewhere. Unless you're standing on exposed bedrock, you know what I mean by bedrock? Like the solid, contiguous rock that goes straight down to the magma. So, unless you're standing on bedrock, there's water underneath you somewhere. Well, you can stand on bedrock on the sides of some rivers, because a lot of rivers are just eroded into bedrock. If you're standing on top of Half Dome, there's no dirt between the top of Half Dome and the lava. You go like Half Dome, lava. That's true bedrock. That's what we mean by bed. It's like the bottom. So there's nothing porous between your socks and the magma if you're standing on Half Dome. So there, rainfall hits Half Dome and then runs off sideways. But that's less than 1% of the land mass of the Earth. Otherwise, in the other 99% of that land mass, there's water underneath you everywhere. Our groundwater here is probably 12 to 15 feet down. Like, if you had a shovel and a strong bat, you could probably get there in a day or two. On West Camino Cielo, where I live, which is the top of the range, like I live like pretty darn near the very top of the Coast Range. I mean, I don't live there anymore, where I own property and I used to live for many years. On top of West Camino Cielo, the groundwater there is like 600 feet down. But it's there. No, I'm lying, 200 feet. 200 feet. I totally made that up. 200 feet. Almost anywhere you are, there's water underneath you. And gravity is still happening, and that water is just percolating through the dirt on its way out to the ocean. If we stop all the rainfall on the entire planet, eventually the ocean level will rise a little bit, and all the groundwater will reach sea level and then flatten out. Does that make sense to everybody? Because groundwater is falling slowly with all that rock in the way on its way to the ocean. Now, here's a big difference between groundwater and surface water. Imagine I grab one of those orange buckets from the back of the room, and I go over to a bathtub that's full of water. I grab a scoop of bath water in my bucket, and I yard the bucket out of the bath. Is that going to leave a depression in the bath water? Which is it? Yeah or no? No?
Well, like right away?
I don't know. Yes? No? This is how the sure of herself. Bath water.
Well, like, let's just a second, then it'll all disperse and find out.
Now we're getting a little smarter, yes.
Good question.
No, did you pay attention?
It'll make it stretching, but then it'll just like bring out.
You know, yeah. That was very convincing. So, yeah, you throw the smile, and it's like, oh, okay, it has to go, whatever you want. In case you didn't know this, for a very, very, very split second, yeah, there will actually be like a depression with a spike in the middle from the drag. So you'll have like your bathtub water level, and it'll have like a little spout in the middle, and then for just a very split second, you'll have that, and then it'll go, and it'll level itself. So the rest of the bathtub will fall, and the pressures will equalize as the stuff underneath the bucket rises. We're talking hundredths of a second, I mean very short split seconds. And then the water will level right away, right? There's this funny thing that happens though. Underground, when we're talking about groundwater, I don't mean to suggest that there is an ocean underground of contiguous water. It's just gaps in the rock with water moving through the gaps in the rock. Does that make sense to everyone? And the rock will slow down that water. So in the ground, if I grab a bucket of water, that's going to leave a depression for a while. It's called a cone of depression. Because there's a little time lag. The water is going to rush in and that'll level itself out, but it takes longer because the water is moving through rocks. This is a key issue. Let me phrase this differently, and maybe you'll see why I'm doing it. Imagine I take my bucket full of water, I go over to the bathtub, and I pour the water into the bathtub. Is that going to leave a huge pile of water in the middle of the bathtub?
No.
Yeah, most probably not. Most probably, as I add water, it will continuously level itself. But not in the ground, because the water in the ground is slower. So if you could please look up, the place where the water enters the dirt and goes into the groundwater, it's going to leave a recharge mound. That's a technical term. The cone of depression, where the water's been sucked out and takes a while to level itself, and then a recharge mound, where the water's been added and takes a while to flatten out. Remember, there's like a delay, because the water hasn't squeezed through the rocks. So all the rain that fell a month ago went out to the ocean via the creeks in a day or two. If it went into the ground, it's still bumbling its way slowly through the earth, going to reach the ocean soon. Does that make sense to everybody? The delay because it's moving through rocks, is it too obvious? Am I like moving too slow? One last thing, look at this crazy concept. The groundwater is often, please look up, contiguous with streams. We call that a discharge zone because it technically exits the ground and fills a stream. Another way to say it is, erosion has exposed the aquifer. So you're right, yes, I'm not saying no. I'm saying, and another way to think of that is, there's actually, you've exposed to the surface the rock that holds water. So where the rock is gone, the water will still level and fill that in as a stream. Yeah?
If 2%, or it takes 2 days for the creek to suck down all the water to the ocean.
Yeah.
How long does it take for it to like bumble the earth?
Really depends on the porosity of your aquifer. There are what are called fast-flowing aquifers.
Would that be like on right here?
No, I really don't know. My hunch is that Santa Barbara's aquifer is low porosity because most of our soils underneath us are alluvial. They're really fine. This is a wetland. So we're probably standing on fine soil for many hundreds of feet.
So that make it easier.
I think I make it slower because the water runs into more things.
Oh, rather than just like huge rocks that you have to really.
Exactly. That would be called high porosity. So
Would that be up in the mountains where like.
That's what I would suspect. Yeah.
Is that why the water is so far down?
Maybe. Maybe.
And then it's so low here.
Maybe. That's what I would assume. Yeah. These are all, there's people who are experts, not me. Yeah.
Wait, so below the water table, is there groundwater all the way to bedrock, or like